one just below that. Heating gas while volume remains constant. It's a micro diagram. Heating gas while volume remains constant. We are doing the practice sheet. Nope. Yeah, this one here.
There's no heat in this one?
There is
There is heat in this one?
Yes. Heat's the input. And then it's increase in speed.
Oops. It's not that hard, so it's only like, you only have like 4 options. So
Heat.
yeah.
That means
Is there an output? The volume does not change.
No.
So there's nothing here, right? And what about down here?
increase in speed.
Increase in kinetic energy. Same.
It's got to be one of these.
In this
It's gotta be
case,
oval.
all of the energy
That's how these
is
two go
going
together.
to the particles. So what do you think
There's always an
as
arrow
far
and
as
an
the
oval.
speed of the
Maybe
particles
an
in
oval.
this one, where the energy is going to move it and increase the speed, versus the one you just did, where all the energy goes into here? Which one's going to have the
Either one
faster?
of those. But
Mostly this one.
One's going to have the much faster particles. Does that make sense? Pardon? Well, we're gonna do a couple more, okay? I'm just gonna try and pick ones that are. Okay. Okay, try the one to the right of that. Micro IO cooling gas at constant volume. Cooling gas
There's no heat.
at
Goes the
constant
other way.
volume. What are you gonna start with? It's a micro.
Box.
Box with particles, you've got one of the 3 points. Box
Bless
with
you.
particles gets you a point.
He's coming out of it.
You're cooling the gas, so does the heat go out and then the particles slow down, or do the particles slow down and then the heat goes out? You have to think about that. What comes first?
You're in heat loss.
Oh, wait, what comes first?
Heat.
It was on the other side. It's supposed to be on this side, right?
Yeah.
But going that way.
Mm-hmm.
It's going away from the box.
Right, because
So
it's
it's a-
going from the hot to the cold.
Right, because it's
Then it's a
converting.
decrease in kinetic energy.
Correct. I can't draw arrows for crap today. I'm going to honestly say, I like these better.
Huh?
I like these better.
Yeah. Go and turn it easier to talk to
Mm-hmm.
No, it doesn't matter, because it's still going out.
If
right?
you,
It doesn't matter what
Okay.
you say.
it really should be here. You'll get a half point off if you put it here. Because you have to think of the sequence of events,
In
okay?
231, yeah, he told us it matters.
Oh, Dr. Ray told you, didn't he?
Yeah.
Oh,
So, yeah, that's why I
interesting.
just told.
Okay, well, it hardly matters. You'll just lose a half a point, right? So it hardly matters.
Everybody knows.
Okay. All right. Does that make sense?
Mm-hmm.
Why does it matter what way the arrow goes?
So the heat energy leaves the system.
Because it goes from hot to cold.
Right.
So when you put something in a cooler, okay, what happens is that the the thing you put in the cooler is warmer.
Right.
And heat always goes from the high temperature to the low temperature. So it's going to, instead of the cold going into that steak or whatever you put in there, okay? However warm it is, that's gonna go out, and then the particles will slow down. It's gonna cool down.
Do you remember the lava lamp scenario where the heat started making the lava and the lava lamp go up?
I don't recall.
Did you
that
take the
one.
earth science class, 232?
No.
Okay.
I only took 231. That's
Well, you know how the lava lamp works, right? It heats on the bottom, and then the lava lamps, the globs float up and then float down. Basically, what the arrows are showing you is how those are moving up for heat, away from the heat, and then when they cool down, it drops back down.
Oh.
So you're starting the process over again. So the heat is moving away from the particles.
Oh.
That's
So however it works for you to think about it, does any, Bridget, what's your question?
Or sorry, would you mind if I just turn my computer around and recorded the session?
Oh, I'll find it
Just
out.
making sure it's
Yeah.
okay with you.
Yeah, it's fine.
Is there a handout study guide?
No, you're supposed to print out your own study guide,
Okay.
but I did print this out. And we've
do I
circled
do?
these
Just hold it?
two.
Just hold it.
because these are
And
the
then
only
there's
two we're
Zoom.
gonna deal with.
Up.
And we're working on this
I just
sheet
held it.
that you.
Well, like that top diagram's so small.
yeah.
Okay. So, let's leave this for now and we'll come back to it, okay? Let's look at the homework that you just did. The homework, chapter 4, activity 3. Activity 3, homework 1, the summarizing questions. Activity 3, homework 1, the summarizing questions. Remember, you are going to get a 0 out of 10 on the book check if you are not writing in your book. You cannot magically do this without writing in your book, okay? You cannot do it.
So for the book check, you're not so much worried about having like the perfect complete sentences, you just want to see us writing.
I want to see you ruining the book so that you can't sell it to someone and cheat these people out of their money that they deserve.
I've done it.
This curriculum
Oh, I'm
is so
more than
well done.
scribbling.
These people worked so hard to make it what it is. It's so elegant. Wait till you see the chemistry chapter. You won't believe how easy chemistry is, the way that they do it.
Activity 3, homework
It's-
1.
So that's what I want to see. Okay? That's why I wanted to see you writing your name. Yeah, but you gotta write your name on here. You gotta deface it. I want you to ruin this book. Okay. All right. So let's look at those summarizing questions. We're gonna see, what page is it? Chapter 4, activity 3, homework 1, page 71, 4-71.
Right here.
71, she said.
71.
Okay.
Summarizing.
That's when it starts.
Yeah, no. The summarizing are page 79.
Okay, and then what we're looking at is the things on 4-80. Okay. So these gave some people some problems. I'm gonna reiterate to you again that pressure is related to collisions per second per area times oomph per collision. Okay? You see those last 3 boxes? The last 3 boxes? You see how 1 is collisions per second per area, 1 is oomph per collision, and 1 is pressure? All right? And we're going to put this up. We're recording it so we can put it up on Canvas. Okay? Okay, now, those 3, it's not really an equation, but if you think of it as an equation, it's going to help you immensely. Okay? So if you think of it as an equation, if collisions per second per area increases, so we'll use a plus. Let's just say increasing is like a +1. And if oomph per collision stays the same, so we'll call that a 0, you've got a +1, forget about the times, because like I said, it's not an equation, but just think of it as, you've got a +1 and a 0. What must be true about pressure?
Pressure increases.
It would be a +1, it's going to increase, okay? So a plus one is like increasing. Okay, this is like the same. What if we have collisions per second per area decreasing, we'll call that a -1, and oomph staying the same? What do you know must happen with the pressure?
Decrease.
Decrease
It must.
as well as volume too, right?
That would be a -1. Think of it as a -1 is equal to -1 plus 0. Okay, if you think of it that way, it's going to help you so much. Just simplify it. It really isn't an equation because this is times and blah, blah, blah. But I'm telling you, it will make more sense that way. Look at your answers now and look at those last
Who's
three
willing to
in
hold
your
this up?
answers. Maybe you don't have them in the book. But make sure that those last three make sense. Okay? Yes?
So in the parentheses, you're adding the +1 plus the 0. You're not doing the multiplication. Am I
Right,
thinking
you're
too
just
far
saying,
into
This is
it?
a +1, this is a 0, so this has to be a +1.
Okay.
But it really isn't an
It's
equation.
just to show how those three relate to
It's
each other.
Okay.
just pressure
If one of
is
those two,
related
then
to.
pressure's
This
gotta do
symbol
something.
means
If one of those two,
related
then
to.
pressure's gotta do something.
Okay.
But if you want to make it easy on yourself, you're going to think of it that way. Okay? So in number 1, somebody read what number 1 says. Go ahead. Daniel.
From exploration 1, fill in the Maxwell micro table next to show that if the volume and total number of particles remain constant, and if the temperature increases, the pressure will also increase.
Okay.
What page are we on?
She just read on 79. Okay? On 79. So what did you say now? Read the thing again.
It says